G'day chemistry students and welcome to Module 5, the first of 4 modules for the Year 12 component of the course. This module is all about equilibrium and acid reactions. This module begins to unpack a lot of chemical reactions that you actually already know about, but we begin to explore them in a lot more depth and begin to see how a lot of reactions are actually able to go in a forward and reverse direction simultaneously. And this comes under this umbrella of the concept of equilibrium. Now, you may see and hear of equilibrium, and this word gets used quite a lot in most areas of science. For chemistry, it's quite different. We're looking at this concept of balance, but in a very specific way for chemical reactions. Let's get into our first lesson. We're looking at dot point 5.1.1 and the general concept of reversibility, a concept that I've talked about a little bit at some stages of the Year 11 course, but a concept that we will break down in a lot of detail in this term and this module. So first off, I just want to talk generally about what a reversible process is. And it's a process that you can do one way, and then the reverse of that is also possible. So, for example, if I push in a spring, the reverse process of the spring pushing back out is also possible. We also have the idea of condensation and evaporation. Water, which is gas, condensing and forming into a liquid, and water, which is liquid, being able to evaporate and turn into a gas. The reverse and the forward process are both able to happen. Now, there's a little bit of a myth that within chemistry, chemical processes are not reversible, and that's probably partially to the way that we teach chemistry at the very beginning of your learning in Year 7 and 8 in particular. What we look at is the idea that it's quite easy to distinguish between some of these physical processes that are here, physical changes, and chemical changes by reversibility, because within the day-to-day, we generally don't see processes happening in a forward and reverse direction. So for example, we usually say, well, you can't uncook an egg, you can't uncook a steak. Therefore, because it's a chemical process, because we can't reverse it, because we can't turn it back to those original reagents, those raw proteins, etc., that tells us that the chemical processes that we see from day to day are never reversible. And we kind of give a blanket definition, which is not entirely true. Technically, you could uncook a steak or an egg. However, that process is exceptionally complex, requires large amounts of energy, and is in practice impossible to do, but theoretically it is something that you would be able to reverse engineer in some way, shape or form. The way that I've sort of expressed this a little bit to sort of help as well, I drew up a little bit of a diagram to help unpack some of these ideas. So here I have my forward process in which a red, a green and a blue atom all react to form one molecule. And the reverse process is the decomposition of this molecule, the red, green, blue molecule breaking down into its atomic parts. And that's our reverse process. And what I've highlighted is that you can have different pathways to reach the start and the end point. So the starting point of the forward process being our 3 atoms, the end point being the molecule at the end. And the way that I've shown the forward process is that this intermediate step shows the formation of a red-green molecule, and that the blue atom forms on the molecule afterwards. So that's a multi-step process. And that the reverse process actually looks a little bit different. That we have our molecule and the bond between the red and green atoms actually breaking first, rather than the reverse process literally being a direct copy of this forward process. And hopefully that sort of helps to exemplify the idea that even though you might go through one process to get from reactant to product, the reverse process to get from product to reactant, so for example, our uncooking of steak or eggs, going from cooked to uncooked, the pathway to get to that uncooked state may be drastically different. And this is definitely an oversimplification of how complex that purple reversible process would look. One example that you should be familiar with already of a chemical process that is reversible is photosynthesis and respiration. In these processes, what we have are reactants forming into products, but the reactants and products are flipped. So in photosynthesis, we have carbon dioxide and water forming glucose and oxygen particles. Whereas in the reverse, when the plant respires, those sugars are burnt in the presence of oxygen to reform carbon dioxide and water, the original reactants. Now, previously, these would have been considered to be non-reversible processes a lot of the time. That's mostly because of this arrow here that it only goes in one direction, or what we call a unidirectional process. And while that's still technically true of chemical processes like photosynthesis and respiration, they don't exactly happen in the same place at the same time. The reactants and products are still able to react in one direction and react in the reverse. So I guess we're sort of broadening our definition of what reversible means in this module. And it's simply the idea, if you have a starting set of reactants and it forms products, if you can get those products to turn back into those reactants, whatever pathway they take, we would consider that process to be reversible. Now in the next video, we're going to take that definition quite a bit further and look at some systems in which the forward and reverse process can happen at the same time. In other words, equilibrium. We're also going to be looking at some systems that we would consider to be reversible, but not actually in equilibrium. They do exist as well. But yeah, we'll look at that in the next lesson. And until then, have a good one.